Hello friends, welcome to this channel. Today I am going to discuss about the concept of applications of statistics in healthcare quality improvement. Actually I am planning to publish some series of videos for healthcare quality improvement. These videos mostly suitable for CPHQ examination preparation, also for MBA quantitative techniques examination preparation, uh, even for nursing biostatistics examination preparation, and as well as their research activities and all other allied statistics subjects. Okay, this is the list of chapters as per CPHQ curriculum. I mean the certified professional in healthcare quality. This is only under statistics. The first one is data. Introduction about data, and the second one is data types. Then descriptive statistics. There are three under descriptive. First one is data presentation by table, data presentation by graph or diagram, then data presentation by numerical value. Under numerical, there are two subclasses: measures of central tendency, the measures of dispersion, and then fourth one is correlation analysis, and next one is the regression analysis. The next chapter in statistics, inferential statistics. Under inferential statistics, there are three: sampling theory, testing of hypothesis, estimation theory, and the final one, statistical process control. There are four tools comes under statistical process control. The first one is Pareto chart, run chart, control chart, and process capability analysis. So these are the techniques and tools as per the CPHQ. These are the tools in statistics as per the CPHQ curriculum. Okay, we'll see what is data and its types of data. Actually, data play a very important role in statistics, because without data we cannot do any statistical analysis. What is the definition of data? As per the literature, data is the numerical statement of facts. Simply, it's a numerical statement about a particular process. One more definition about data. Data is the measurements or observation of a variable. It's a collection of measurement or observation of a particular variable or a particular process. Okay, what is the purpose of data collection, especially in healthcare quality improvement? First, we need to collect data for a particular process. Then we should do analysis. Analysis will give some information. It may be positive or negative. Then we need to make some action plan, and we should implement. Then we'll get better outcomes. So this is the purpose of data collection and data management in healthcare quality improvement. We'll see the types of data in statistics. Initially, there are two types of data. One is quantitative, another one is qualitative. Quantitative data is also called as numeric data, and qualitative non-numeric data. Then under quantitative, there are two sub-classification. One is continuous, another one is discrete. Continuous and discrete both comes under quantity. Then what is the exact difference between continuous and discrete? Continuous is measurable data and discrete is countable data. Examples for measurable data, for example, patient height, measurable. BMI comes under measurable data. Weight of a particular patient, measurable. So all measurable data comes under continuous. Whereas discrete is just number of item, countable terms. For example, number of children in a particular family, it may be 0 or 1 or 2 or 3 or 4. Here we cannot write 1.4 children in a family. There is no meaning for 1.4. One more example for discrete data, number of patients in a particular ward. So all countable numbers comes under discrete data. This is the exact difference between continuous and discrete. Now we'll move to qualitative. Qualitative is also called as categorical data or non-numeric. Categorical, but there are two types of categorical. One is unordered categorical and ordered categorical. Unordered categorical data is the nominal data. There is no particular order. For example, gender. So there are two possibility for gender. One is male, another one is female. But here there is no standard order to represent this gender distribution. Even first one is we can write male, another one is female, or first one is female, another one is male. So there is no particular order to present this data. But whereas ordinal follows some order. For example, severity of disease. So severity is there is the order. It may be mild or moderate or severe. Even the Likert scale is the best example for ordinal scale because there is an order. Strongly agree, neutral, disagree, strongly disagree. So all ordered categorical data comes under ordinal. So both are non-numeric. There is no exact number for this type of data. But the difference is nominal is unordered category and ordinal is ordered category. Okay, we'll see the example, very basic example for the classification of types of data. The first one is, in the first one, I'm going to measure weight of these apples. It's around 900 gram. So this comes under which type of data? Continuous data, because it is measurable. What about the second one is here I'm going to find out the number of apples in this basket. Just only number of apples. So number of apples is discrete because it's countable. The next one is, in this example, just I'm going to classify these apples by its color. No numerical value, just by colors, by its colors. The first one is green, red and yellow. So even we can write first one is golden, another one is red color, and next one is green color. There is no particular order to represent these types of apples, just by its color. So nominal data. And the last one is, here I am going to classify these apples by its size, small one, medium and large. There is no numerical value, but I am classifying by its size. This is the best example of ordinal data because there's an order for this classification: small, medium, moderate. So this is the best example for the classification of all four types of data: measurable continuous data, number of apples is a discrete data, apples by its color is nominal data, and apples by its size is ordinal data. Yeah, here we'll see some comparison of types of data. I have four columns in this table. The first one is variables, the next one is how to get, and next one is value, for example, and what is the exact type of data. So for example, age, how to get age, inquire. Okay, for example, 35 years, so continuous data. Even for age we can write 35.1, 35.2, 35.3. Fractions are possible. So fractions always comes under continuous data. If it is possible to represent fractional number, then it will be continuous data. Definitely, sure. And what about the height? We can measure. How to get? Measure. For example, 140 centimeter. Even we can use 140.5. We can use fraction. And what is this type of data? Continuous data. Then what about BMI? BMI, how to get? Compute, because there's a formula for BMI. For example, 36.1. See, this is also fractional number. So fractionals always comes under continuous data. What's the next one is gender. Gender, how to get? Just observe. For example, male. So gender is categorical and there is no order. So comes under which one? Unordered, nominal data. The next one is number of patients. Number of patients, how to get? Inquire. For example, number of patients in ward A, 40. Is it possible to use fractional number? No, because this is number. Should be whole number. Should be either 40 or 30 or 10 or even 0 also possible, but 1.1 is not possible. So this is just number of item, number of patients. So comes under which type of data? Discrete, because countable. And one more variable, physician attitude. How to get? Inquire. Actually, physician attitude, there are many scales for the measurement of attitude. For example, physician attitude, poor, good, very good, or satisfied, not satisfied, moderately satisfied. So this is exactly ordinal data because there is order. We'll see some similar CPHQ question related to data and data types. See, first one is question number 98. Which of the following may be considered examples of discrete variables? There are four options are given. First one is height and weight. Second one is community acquired and nosocomial infection rate. Third one is surgical or emergency department response time. And fourth one is patient visits in the month of May and June. We need to choose the correct answer among the four options. Which one is the discrete variable? So as I said, what is discrete variable? Discrete variable is nothing but countable data, number of items. So what about the first one is height and weight is not number of item, it's measurable. So first one is not a correct one. What about second one is community acquired and nosocomial infection rate? Measurable, because this is rate, not number of cases. What about third one is surgical or emergency department response time, also measurable because it's time. And what about fourth one is patient visit in the month of May and June. This is just number of patients seen during the month of May and June. So number of patients comes under discrete variable. So therefore the correct answer is the fourth one, D.